This is a session on MonteAI for your detection engineering and our MonteAI Copilot to help you build threat hunting queries using AI. So just a quick level set about Anvilogic. We're a detection engineering platform. We really help with being able to build, deploy, and maintain detection code for your security operations center. And we are unique because we work with different logging platforms. So we're agnostic to the data layer. So we work across Snowflake, Splunk, Azure. Those are kind of the primary platforms that we integrate with. And the idea is to kind of separate out your analytic layer from your logging layer. So making sure that you can run consistent analytics for your security operations center on top of your data platforms where you store your security logs. Basically, our platform helps you with being able to bring in other security vendor alerts as well. So if you have security tools that also generate alerts, we make it really easy for you to bring those into your security operations center, standardize how you store those alerts so that you can build correlation and threat hunting queries on top of that. Now, what I'm really excited to show you today is an innovative way of how we're allowing security teams to build detection content. So what you're about to see here is our unique way to build detection queries using a drag and drop interface. This type of detection building can be done regardless of the underlying data platform. So what I'm showing you right now is our integration with Snowflake. So a lot of the detections are going to be written in SQL, but the same concept works across Splunk, and then you're writing those detections in SPL, or Azure, which would be writing those detections in KQL. So before we get kind of into it, I think one of the things I struggled with, especially because I worked in security operations for a long time and we were heavy users of Splunk, so I was very good at SPL. And then when we started to build different detections using SQL, I was a little bit rusty on SQL. Didn't necessarily understand the right ways to go about building detections using SQL. So what we did was we developed a generative AI capability that helps you write SQL detections. It will also help you writing SPL detections and or helping you write KQL detections. But the idea is you can kind of use that as your code pilot when you're building detection queries and or hunting queries to kind of fast track your ability to deploy those. So pretty much how it works, just to get started in our platform, is we make it really easy for you to kind of gather the data that you want to search against. So instead of focusing on what are all the tables that I need to query or how many joins do I need to do, we make it easy for you to kind of just gather the data for the relevant security data that you're looking for, make it easy for you to understand the schema inside of that data set. So in this case, right, I'm pretty quickly able to kind of gather my EDR data and search for some PowerShell activity inside of my EDR data set. Executing these queries is all done through our UI capability. So what this is doing is it's executing code down on the underlying platform. In this case, it's Snowflake, and you're able to kind of get the results back. Now, if I'm hunting through this data, right, and I'm just looking for PowerShell data, I think one of the things, like if I'm doing kind of a threat hunt here, is I want to try and find interesting activity that maybe I can keep track of, but I don't necessarily want to generate too many results because those are going to be hard to look through as you're building that out. So what I want to do is kind of try to continue to build off this query. So right now I'm just looking for PowerShell activity. Maybe I want to start to look for additional PowerShell activity. So this is where I can go in and find maybe invoke expression events. And maybe if I don't remember the exact syntax or the exact text for to be able to do that, I can ask my MonteAI assistant to kind of build that query for me. So right now I'm looking for basically the same thing, PowerShell executions with invoke expressions and finding events. So I started with 500 events, and now I'm going to look for some additional, more specific activity. Still at about 78 events, right? So still, I think, need to filter it down a little bit more. So this is where I'm able to start to maybe filter my data a little bit, try to understand the context of which I'm getting at. But maybe I also want to look for additional activity, right? So maybe I want to also look for PowerShell activity where there's kind of a web request in that, right? So maybe I'm going to ask to also find me PowerShell activity that creates a web request, right? So now if you can see, what it did was it added the web request PowerShell expression to my query. So it's kind of continually building the query that I'm able to then copy and paste that into my code block to find the additional events I'm looking for. So like I said, what I did is I added the invoke web request. That's going to update my regex to include that OR statement for me. And then I'm able to kind of search that data and see what the results are when I get back. Now, as you can see, I'm back to 500, right? So I kind of went from 500 events to 78 events, and now I'm back to 500 events. So still need to do a lot more filtering here, but it looks like I have kind of the types of PowerShell activity I'm looking for. So maybe now I want to look for a specific activity, like only give me the requests that contain hits to an IPv4 address, right? So maybe those are a little bit more suspicious. Somebody using a PowerShell expression to call directly to an IP address, potentially to deliver malware or to post files, might try to limit my data set, so I'm going to bring that back down. And as you can see, it added the regex for filtering on IP addresses, which makes it easy for me to do. I didn't have to Google it or kind of open it up in a separate tab. And now you can see I got my events back down to about 173, potentially some interesting parent process names there, potentially malware. But the idea is what I was able to do is basically build a pretty good hunting query that I'm then able to search for the results. Now, I'm not done yet. As you can kind of see, as you scroll down, I see a lot of internal web requests here. I see callouts to local host and some internal IPs. So maybe I also want to remove kind of that noise, right? So I don't necessarily want to look for events that are posting information to local hosts. Maybe some security team is doing some testing. So I'm going to go back to MonteAI and I'm going to say, just remove the local host IP addresses. So what this is going to do is it's actually going to extend that query once again. It's going to add a not statement to remove request for local host. And like you see there at the end, it added that and not regex like for the process containing local host. And I'm able to kind of paste that query in really, really quickly and find those events again, removing all of that noise that's potentially testing activity that I don't want to track. And now what I'm able to do is I'm able to execute that query and I'm able to find just the events I care about inside of that event, which is, in this case, it's actually post requests to a Russian IP address, right? Uploads that are potentially interesting, something I might want to hunt on. So this is how you can use our MonteAI capabilities to kind of act as your co-pilot when you are building detections. As you can see there, it took me just a couple of minutes to build, a basic PowerShell threat hunting query that I can then go and deploy and create as a use case. So now if I wanted to save this inside of the Anvilogic platform, maybe I'm kind of done with this. I found the events I'm looking for and I want to save this so that it continually runs and tracks the activity. I'm able to kind of bring all the other relevant components to my detection framework. I can group my events if I want to. I can add a definition. Definition is kind of like a one-liner to help your triage team or anybody that's looking at the event to better understand kind of the results that are coming out of it. The cool thing about this is you're able to kind of do tokenized field names, so I can kind of write the sentence that I want. In this case, I'm looking for suspicious PowerShell events. And then I'm able to add kind of the host information there, which will display the value. And then I'm able to track the actual command and process that was run, meaning that when the detection team or the threat analyst or even the triage team is looking at this event, they're able to see that one-liner description that kind of describes the use case that I was building out. Just saves time when somebody's trying to triage the activity. And when you go and actually re-execute that, you can kind of see when this finds it, you can actually see the one-liner that the detection team or the triage team would look at when they're investigating this event. So you can see here, if I scroll over to the right, which I'm about to do in a second, I'm able to see that definition. In this case, it will show me that exact events with the tokenized activity, meaning that this is a PowerShell request, and the actual web request I was looking for was that suspicious call out. So now I'm able to, if I want, I can see the code view. Each of those individual components are individual lines of SQL that are easy to execute inside of your Snowflake warehouse. But now I can actually save this as a threat hunting use case that maybe I want to track and version control and document for my threat hunting team and even share it with the rest of the members of my team. So I'm just going to give it a name here, just say, hey, this is my hunt looking for suspicious PowerShell activity, specifically web requests to IP addresses. As you can see here, I'm tagging my event with a bunch of different descriptions and different data domains. This helps just to section and organize your detection queries, categorize them a bit. One of the things I really like about the documentation piece that we have here is documenting a use case is always kind of the boring part. Writing the detection is the fun part. So when we go to kind of tag your kill chain events or maybe your MITRE ATT&CK framework, and we also use some machine learning to help with the tagging. So after I'm done just showing you the kill chain phases here, what I'm also going to do is auto compute my MITRE ATT&CK techniques. Right, so that's going to be based on the detection name and the description that I put in there. It's automatically going to tag the MITRE technique that's most relevant. Saves you a bunch of time to have to go in there and add 50 plus tags yourself, right? And maintain the tagging for MITRE ATT&CK is always time consuming, right? So now I'm going to go in and be able to kind of click through, do additional tagging if I want. The thing that's nice about the tagging is that you'll see in a little bit is I'm able to actually add my own custom labels to these tags too. So if I had a really specific use case, maybe I was doing PowerShell threat hunting for a particular incident or something that's more relevant to my organization, I can add those tags and labels. I can even map some things to security controls. And then I'm able to kind of categorize what data I'm looking at so it's a little bit more organized. And then I can save this as a new use case that then is version controlled. So another nice thing about our product is after you've built your detection query, you're able to then version control all of that code. So as you create your own new version, that's going to be version 1. If you make changes to this over time, that would be version 2, version 3, and so on. You have a nice audit history. And then you can easily deploy this down to your connected SIEM. So like I was saying before, this can be Splunk, this can be Snowflake, this can be Azure Sentinel, and that will deploy that use case down to that platform, whatever you have connected, and that will run that event. Now, the reason why I showed all those tags as well is because I want to show what those tags kind of do on the back end. So all of those MITRE taggings that I made, now that I've created that use case, you can see that all of those events are now part of the results of those queries. So this allows you to not only just tag your use cases, but also tag the events and the output that comes back from that. So I can easily see now all these events are tagged with the MITRE technique descriptions and all my other tagging that I did that's easily findable. This is really good from a threat hunting perspective and correlation perspective because now all of those attributes, all of those tags, exploits, everything that I did before is written with those events. So I can do some threat hunting even based on MITRE techniques and things like that. So that is how we were able to build detection queries using MonteAI. Kind of what you saw there. If you have the ability to go in and write detection queries using SQL, even if you're not a SQL expert, you're able to do it in a matter of minutes. You can sign up for a free trial where you can actually test everything that I just showed you for 14 days. And you can play around with building your own queries in SQL and see how far you can get. If you have any questions for me, you can reach me at the booth. But that's it. Thank you for showing up, especially Oscar, for coming all this way to see Anvilogic once again. Appreciate it.